Hello all. We'll start this session in few minutes. Just wait. Let others rejoin. Hello all. So in this session, uh, we will discuss some practical approaches of IoT applications. Okay. So it's hands-on. It's difficult here. Actual hands-on will not be taken place. The thing is, I will present some video where you can see. Just wait. I am having call.
Okay. Welcome back, sir. Please continue. Yeah.
Okay. In this hands-on session, from scratch, IoT applications we will build and how we can interface the sensors with Arduino and all. After that, whatever steps we have done practically in various projects. I'll start with one project. Which is the development of an end-to-end human activity recognition system with the help of accelerometer, and then how we have done the full thing. I'll try to explain. Okay, so here actually I need to play one video. You just let me know after some time whether it is fine or not. I mean, whether the audio is coming or not and all. Just I don't know whether the sound, how the sound will come, but still I'm not sure. I have not done that earlier. So the video is is visible to all along with audio.
So sir, video is visible, but audio is not audible.
Audio is also fine, na? Okay. So let me just start that from the beginning. I will play that. So main thing here, just let me briefly explain that the application is human activity monitoring, and the components we have used is one main component is accelerometer, and then we are having one ADC, analog to digital converter, and then we are having ESP8266 for Wi-Fi transmission of the data. So for that we have used WeMOS D1 development board. Within that, this ESP8266 chip is already inbuilt, and apart from that, accessories like 400 pin breadboards. Then we are having jumper wires and all, and little bit of soldering and all these things are already done with the sensor. So these are the primary components. Now here in this video we will see that how we will connect, and then how to code in the Arduino IDE, then other things subsequently. And now this is the first part of the video, and later on in the second part we will see the evaluation or testing of our all these things. Okay, so I am starting the video. You just keep on watching this one, and then you just in the chat section you just let me know in case of any doubt. I will respond you back in the chat section. Okay.
For that, the data into or VMOS D1. Okay, so for in D1 VMOS, as we can see that there is only one analog pin, right? So there's a issue that how we will be converting or how we will be taking the data if we need to take the data as output. Okay, and then we do have only one input here in VMOS. So how we will be taking? As you can see, this in this diagram project or in this circle. Hi and welcome to the circuit diagram connection. So in this project or in this circuit diagram, we need one accelerometer so that we can get the data of x-axis, y-axis, and z-axis, right? So this is our uh, accelerometer, right? So as you can see, this is VCC, X output, Y output, and Z output, and there is one ground. So we'll be giving the connection of like input as VCC and ground. Okay, then after that we'll be taking output as X out, Y out, and then Z out, right? So for that, so that we'll be taking the data into our VMOS D1. Okay, so for in D1 VMOS, as we can see that there is only one analog pin, right? So there's a issue that how we will be converting or how we will be taking the data if we need to take the data as output. Okay, and then we do have only one input here in VMOS. So how we will be taking? As you can see this in this diagram, It is in the code, there is only A0 is written here, right? And all these are not working. It will not work if you want to use it, it will not work. Only one analog pin is there, and this is connections with P in ground and 3.3 volt, and reset. If you give the reset, then it will reset, and then 5 volt, and here these all are digital pins, right? So only one analog pin is there. How we will be inputting this three data, x-axis, y-axis, or z-axis, three, all of these three axis data into this? So how will we be taking that? So for that thing, what we have used is we have used a multiplexer, right? This is our multiplexer. The name of this multiplexer is ATS 1115, right? So what we'll be doing is we will be taking the data at some like nanosecond interval of time, right? It will be giving data, and then what we'll be doing is at some time we'll be taking data as x, y, and then z. Okay, so it will do our job. This ATS 1115. Right. So you can see that here is SCL, STA, ADDR, ALTR, A0, A1, A3, A2, A3, right? So four analog pin is there. So it is enough for us to do. We can use either from A0 to A2 or A1 to A3, right? So anyone we can use. If we we have four and we can use, we have to choose three. So for that thing, we will be giving the input from here, like we will be taking input from here, and then we will directly connecting to here, and then this will connect to our remote queue, right? So let's go and connect. Let's go ahead and connect to our circuit diagram, right? So let's go and connect with this. This is our x, y, and then z. Three pins again to y, right? And y axis, this one is z axis, right? And then we also need to give some input to this. So VCC and ground, right? So let me give this ground as in green color and VCC as this color. Right. So this one is connected. So what we will be doing is I will be fixing it here somewhere, and I need to give this the data to this. So I cannot fix. So I have just answer that I can fix it here, right? I can fix it here, and then after that I need to give this the data, the ground and VCC. This is our ground and this is VD. Let me connect this V into here as VDD, right? And then ground. Let me connect this ground. This is a ground, and this is the ground, right? So after this, what we will be doing is let me fix. I cannot fix it here. So I'll be doing is I'll be fixing it here. Okay, so that it will be useful for us. It will be fixed here also, and then let's say if I connect this and it will be moving, then our data will not be coming as we want it. So we will be making it as a fixed data, and then it will be used in our waste. So I am fixing this also in the belt, right? So for that, I think I need to use this double-sided tape, right? And then let me fix it here. Okay, as you can see, and now give this to ground, right? And this is VCC or VDD. Sometimes it is VCC, sometimes it is VDD. Right, and this one is our x-axis. This x-axis as A0. Y-axis is A1. then Z axis as input, right? Now we need to click this. Um, I think I need one more keyboard so that I can give this to here as SDA, right? SCL and SDA. If you don't have SDA, one more thing on this. Okay, so I got one more wire. Right. So what I'm doing is SCL and SDA. Right. I'm connecting this both of these one to our digital pin. Okay, this will be converting our the data to digital pin, right? And we'll be taking our input as data, our data as T6 or 27. Anyone I can use it in here. So let me connect this to our SCA to D7 and SCM to D6, right? So our connection is complete. I will be fixing it here, right? So that it also be not moving. So our connection is completed, right? For that, what I will do is I need an bed. I make this. I have bed here. So what I will do is I fixing it here. I have already um, fixed it like a conservative here, right? So our program is done. Okay. So what I need to do is I need to give this to power. As you can see, it is blinking, right? So what I'm doing um, uh, coding and then uploading code to this, and what we need to do is we send our data. We send our data to Google Sheet. Okay. But in Google Sheet, as input and this our business to us. So this will be sending to that to the cloud, and we have written some algorithm that some mathematical calculations that is mean deviation from our whatever the input data has been given. We will be first taking the input, right, so that it will be taking the input as for the training data set, as we can see. It is actually not a machine learning we are using in Google Sheet, but it's a simple mathematical calculation that we will give some user some input. We distribute that input as all all this thing here. Right. So, given all like input the data, right? So I'm getting the code here and I'm putting it here using USB cable. Right. So let's go and see how to do this and do it. Will be displaying anywhere on the screen, right? So you can do the setting accordingly. So this is this. So as we know that we need to write down the code and then upload it. So let me verify whether it is in or so this is visible. Now as we can see, it is compiled. Right, after it is compiled. So for uploading, we need to give our we need to plug in our or Vinomo
What is the
or
business requirement
ESP module,
taking the
whatever we are
here?
doing. So as you can see, it's compilation has been done, and then after that we need to like select this after then port, right? It should be VMOS should be there. Yes, this is we will be using this VMOS D1 album, right? So I will dumping my code to this, and then it will communicate with our Google script or Google Excel sheet server. Okay, whatever we'll be making it. So let's get started. And before doing this, what we need to do is we need to go to the preferences, and then we need to put this book managers some link. This is JSON, right? So that it will take whatever the uh, header files or all other things will be required for the compilation, during the compilation, and then it will require some libraries inbuilt in this JSON, right? Okay. So we need to do what we need to do is we need to include some headers so that we will be using, so that what we will be using will be using ESP266 that is inbuilt on the board of VMOS, right? VMOS T1. So let me do one thing. I will be starting with um, including the libraries, right? That is ESP 8266, and that is Wi-Fi. Right. So we can include all the libraries, whatever the requirement. As I mentioned, we will be using ATS 1115, as I mentioned during the circuit diagram connection. Okay. So we will be using that also here. So let me include this library also. Okay, this is called ATAL and then that is ADS. That's ADS and then 1015 dot H. Right. And then after that we can include our wire that we will be communicating with um, our Arduino. Okay. So we'll be using this also. And then we can use some mathematical calculations if required. So I will be including this library also if required. Right. I don't think so that will be fine, but although I'm including this for the sake of complicity and for the sake of requirement, if in the future we will be requiring, then we can use this. Right. So what we need to do after this is we need to connect our VMOS to the local Wi-Fi. Right. Local, whether we're getting a hotspot or whatever the Wi-Fi is there in router is there in my institute. Okay, so we'll be connecting our VMOS, and then we'll be giving the credentials to our Wi-Fi, and then it will log into that, and then it will use the internet from that Wi-Fi, and then after that it will communicate with our server, right? So for that thing, I need to create one like a constant variable that will be our SSID. Okay, as an SSID and the password will be storing it with the variable name that will be character type. Okay, so let me make it. That is SSID. We can give it to is, and we can give our SSID. Right, we can use our Wi-Fi name here. So I will be getting a hotspot from my laptop only. Okay, so during the testing time, right? So I will be using my hotspot thing only. The name, whatever the name we want to give. Let's say um, demo. Okay, and then I'm getting um, SSID, Wi-Fi or a hotspot with name demo, and then let me this password also. Password that will be our let me give 1 2 3 4 1 to 9 and then the whole number from 1 to 3 1 to 9 right. So after this we need to what we need to do is we need to communicate with our host, that is our scripting excel sheet. At the back end we will be running some scripting language. Okay, then it will communicate with our the data will be sent to this, and then that will execute, that will one application will be deploying, right? So that will be it will deploy, and then it will take the data, and then it will process, and then automatically it will store it into the excel sheet, right? So for that we are using is we will be using a script google.com, right? So for that we can use as it's not int, it might be it is character type, that is we can give it to the name as host, and then we will be giving this as script dot google.com, and what the port it uses is it will be communicating with https, right? So it uses port of 443, right? So for that thing also we need to give, we will store as let me say it as https port, right? That is 443. It is inbuilt whenever we're visiting computer networks. It uses https port, uses 443 port, right? So after this we need to secure our Wi-Fi network. So for that thing we will be writing as Wi-Fi client secure, that is client, right? And then after that we will our Adafruit that we mentioned here. Okay, for the multiplexer ADS 1115 as I mentioned. So for that thing we will be creating one that as Adafruit, and that is ADS 1115, right? That is ADS. And then after that we need to make one fingerprint. Okay, so what I will be doing is I will be getting my fingerprint, whatever the fingerprint is there. So this is my fingerprint. Whenever I will be you can, if you are used working on this, this is for the Linux. If you're working on Linux, then what you can do is you can copy this code, and you can go to the terminal and paste it. It will show the your fingerprint, whatever the fingerprint of your of this server is, right? So this is the server of this script.google.com is to 443. So I'll be using this as an fingerprint, right? So let me make one variable, name it as fingerprint, and that will be our fingerprint as this. So let me copy it from here, right? So this is our fingerprint. Okay, and then after that we will be making deploying our one app that will be running continuously at the back end of the Excel sheet, right? So for that thing, we will be needing the gas ID of that Excel sheet, whatever the web app we will be deploying, right? So from there we can get it, and then I'll be showing in the coming time that how to get that, how to do the setup for getting, how to like how to do the setup for getting the data into Excel sheet, right? How to get the gas ID and how to do all the setups. So let me make this as um, that is gas ID as name, and that will be our this. We can give any name, whatever is comfortable with you. So we will be giving the gas ID whenever we will be deploying it here, right? So let me write it here as to be taken from web app deployment, right? So it will be taken. After that, what we will be doing is, for the first time, we need to connect to our this whatever the thing is there. So our hotspot, right? So for that thing, we will be beginning our setup, and then whatever the pins we are using in that MOS, we will be doing all those things. Okay. So for that, let me start with Wi-Fi dot begin. It will begin our Wi-Fi, right? And we can use any D0, D1, any pin, whatever you are comfortable with, whatever the you are comfortable with that pin, so that it is good for you. And then serial dot. We will be beginning our serial. We will be printing something in our serial monitor. So this is our serial monitor. From here we can get, as you can see, this is the serial monitor. I think it will not show. Nothing is connected to my port. Okay, so I will be using it as let's say like some port thing is there, so we can it will be encoding the data and showing it to the serial monitor, so that some different numbers are there, encoding things are there. We can use all other um, numbers, right? So this is our C begin. Okay, and then after that we will be printing something, print line, right here. And then after that we can print that we are connecting to the so that it will display here on the screen on the serial we are still connecting, right? So serial, the S for serial should be capital, sorry, my bad. Okay, serial dot print, whatever you are comfortable with, you can write it down here. I will be writing as connecting to Wi-Fi, connecting to Wi-Fi, well, and it will be printing on the screen that connecting to Wi-Fi. And then after that, we will print that from which we can print that from which SSID we are communicating with, we are trying to connect with. So we can also print that. Serial print line, and then after that we can print SSID. I might not use SSID. Okay, it will print in new line that what is the SSID that we are printing with, we are communicating with. Okay, and then after that we should start the like Wi-Fi. Okay, so Wi-Fi dot mode, it should change to the mode from off to Wi-Fi SDM, right? And then we will begin the Wi-Fi communication from Wi-Fi dot begin, right? And then with this with SSID, and then with password, then try to communicate with our SSID without hotspot. Okay, so while our Wi-Fi status is off, is not connected, what we can do is we will be printing some test type of thing. And if it is connected, we will be coming to the loop. We can make it a loop inside a loop, so that when until unless it is not connected with our hotspot, what we'll be doing is we will be printing some test type of thing. So let's see. While this is one code. So while we can say that Wi-Fi dot status. Okay, this function, it will show us it will give the status, and then if it is not connected, if it is not equal to connected, right? Till then, we can give a delay for, let's say, 10 seconds. After 10 seconds, again you try, right? That whether try to get the information that whether it is connected or not. If until unless if it is not connected, print something on the screen. That will be whatever we will be printing. Print serial dot print. Let's say I want to print that type of thing, right? It will be, it will print like until unless it is connected, it will print minus 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 that it is not connected. Right? If it will uh, if it will fetch that if the status Wi-Fi dot status will give that it has been connected, then it will come out from the loop while loop, and then it should print the data that that from which SSID or from which thing it has been got um, connected through, right? So we can also print it that also serial dot print, print the what we can print that Wi-Fi is connected, right? We give the Wi-Fi is, give the user as information as it has been connected, right? And then after that, we can print out the IP address of that local server, also local host or local, we can say the local IP address of that ESP module, or that or else Windows module, right? So we can print this also as serial dot print IP IP address equal, okay, and then we can print it as serial dot print, that is Wi-Fi dot local IP, right? Wi-Fi dot local IP, right? It will print the local IP address of that Wi-Fi, whatever the with what IP address it has been connected through, right? So this has been done. We have done all the setups, whatever the setup is required, so that it will connect with our local host or local, we can say local hotspot, all right, and then it will do all the setups. So now our recipe 8266 or our VMOS has been connected through the internet or through the Wi-Fi. It has been connected. It has been connected through the Wi-Fi. It means it has been connected through the internet, right? So what we need to do is in the next step, we need to take the data from here, okay, and then we need to send the data continuously to the after each some interval of time.
Okay, so this is the end of part one. So don't worry about the less font size and all. So as this is pre-recorded, so I cannot increase the font right now. But I am uploading the videos in Google Drive, and within few minutes you will get the links. Okay. So till now, whatever you have watched is basically the connection of the actual devices, and then as we are having ESP8266, which is the main component to transfer the data to cloud or remote server. So with the help of that, we have the necessary coding, which is already displayed in the video. So with the help of that coding, and then the code will be dumped into that development board we must given, and after that the data you will be able to send into the server. We have used our Google spreadsheet here for that purpose. Okay, and when it will go to the Google spreadsheet thing, then after that automatic analysis will take place there, and you will able to recognize the human activity. Okay, so in part two of the video, I am playing that video, so maybe there also you will find little bit problem, but I think it will not be a big problem, because I'm going to share the video links. Okay, so just you try to see whatever you can see, or you are able to see in your screen. After that, for your reference, obviously I will share the video links here with Google Drive link. Okay, so now let me play the part one and share that.
Okay, so let's go to this loop thing, that how it works. And what we'll be doing is we'll be writing data. Okay, so let's go to this loop thing, that how it works. And what we'll be doing is we'll be writing the code that will send our data to the server continuously, right? So for that, what we need is to be sending three data. So I'll be creating three variables. Let me create um integer variable of type 16 bit. It is ADC0, let's say ADC1, and ADC2. Whatever the naming you want to give, you can give according to you, according to your convenience, right? So after this, we need to read the data, this ADC 0, 1, and 2, because we need only three data, that is x-axis, y-axis, and z-axis. So now we can initialize this as ADC 0 equal to our ADS, that is triple on 5, like ADC triple on 5. From there, we will be reading the data because it is getting synchronized with our VMOS. Okay, and then it is sending the data to through that ADS triple on 5, right? As I mentioned in the circuit diagram also when we were discussing. So we will be reading the data from ADS, from read the data as ATC. This is a function that is single-handed, right? That the pin will be using for this ATC 0 is, that is pin 0. That is, it means that read the data from singly ended, that is pin 0, that will be acting our as the name of that ATC 0 is x-axis, right? Similarly, we will be taking the two more data, that is ATC 1, that is ADS dot read, ATC underscore single-ended, right? That will be our pin 1, and then after that ATC 2, that is z-axis, and then ATC dot read ATC single, right? So we have accumulated the data that is in three variables, that is ATC 0, 1 and 2, that is x-axis, y-axis and z-axis. So for that, for the verification that whatever the data we are getting in from our sensor, we will be printing it to a serial monitor. So for serial monitor, as we know that we can use serial.print, right? For that we are using first thing, that is x-axis. Let's say x-axis equals, and then I'll be printing the data of ATC 0, that is our x-axis. Okay, so let me do again serial dot print in the next line, print that in the same line, but after this it will print the next line, right? So I'll be printing this as ATC 0, that is our x-axis value, right? Similarly, we can use serial dot print y-axis, okay, so that we can visualize. All right, so y-axis equals this, and then we can use it as serial dot print line, okay, and then that will be ATC1, okay, and then after this we can use serial dot print, that will be our z-axis, right? So let's say z-axis, right, equals serial dot print, that is ATC1 serial dot print line, and this line is printing like it is printing in the next line, right? It is printing in the next line whatever the data it will be printing, okay. So after this, what we'll be giving is we'll be giving some delay, so that it will after some delay it will automatically repeat that thing, right? And after that we'll make a function, that is the name of that function will be send data, and we'll be passing all these three data, whatever the data we are accumulating here, right? So we can give the delay as 100, that is 10 milliseconds, okay. And then after that, what I want to do is, whenever the data will send through, whenever I am sending the data, right? So first it will blink. I want it in my VMOS to blink it first, and then after that I will call the function with the three parameters, that will be ATC 0, 1 and 2, okay. And then after that it will again the LED will be glow off, right? It will glow and then send the data, that call the function, and then after that it will the LED will be switch off, right? So for that thing we can write it as digital, right? That will be our what I will be doing is I will be using the input LED, okay, that is inside my VMOS. So I can call this as LED built-in, right? And that should be high, right? And after that I will call the function that will send, that will take the string data, that it is 0, 1 and 2, and then after that what I will be doing is I will be again a digital light, that LED built-in should be low, right? So call the function. I will make this function as in the next thing, right? So that I am using ATC 0. I'll be calling this function with three parameters, that ATC 0, ATC 1, and then ATC 2, right? and then it will call the function. Then after that, again we want, as I mentioned, digital,
Okay.
right?
You can taste. Yes.
LED built in,
No, from there I cannot access your system. But
built in, it should turn off. It should turn off. So it will be low, right? So till now everything is done, so that we can it will run in the loop, right? So now next what we want to do is we want to define this function, that is send data. Okay, so let's go in the next line and write it down. So what I will be taking is a void, and the name of the function is, as I mentioned, that is send data, right? So let me give it as capital S, or anything we can give, right? Um, let's say send data, right? Send data. Okay, then whatever the in this function, whatever the parameters we are passing, we need to accept that parameters. So I will be taking the parameters as int, that is let's make one variable that is int x, right? X-axis, the value of x-axis is x, int x, and then int y. Okay, it is one is y, and then int z, right? So three variables, it will take the all the like of function parameters, right? So after this, we what we need to do is we need to connect our host, that is script.google.com, because we are dealing with that thing. So before that, what I need to do is I need to go to our Google sheet. Okay, and then I will be creating one sheet, Excel sheet, and then I will be deploying that Excel sheet as a web app. Okay, and then and then after that, what I mentioned in here is, just now I mentioned, that is this one, gas ID. So we'll be taking the gas ID from there only, and then it will I will be making one URL. Okay, and again in a repeated way, it will it will send that URL only. We will be sending the URL within that app, then that app will execute that URL. Okay, that will be URL into that uh, we can say that in Excel sheet, and then it will whenever it will execute the JavaScript thing, the scripting language, and it will fetch only extract the three axis value x, y, and z, and then after that it will store the data into our Excel sheet, right? So let's switch to this. So this is my email ID. I'll be opening this sheet. Okay, so I need to make one blank spreadsheet, right? And then name it as whatever you want. Uh, in my case, I'm giving it as a demo, right? And then after that, we need to go to tool, a script editor, right? And then in this script editor, due to lack of time, I will not be discussing that what script you can go through this script according to you, right? So I will be copying this script from internet, right? And then I will be deploying this as well. And then after that, will be getting the gas ID and then links, and then I will be executing that thing again and again, right? So it should open. This script editor should open. Yeah, right. So here, this is our app script. As you can see, I was discussing that this is our web app. Okay, so I can give it name as demo again. Okay, then rename. We can give it a name as demo, and then okay, it should rename. Yeah. So I will be copying this the one script that is from internet, right? And then I'll be pasting it here. You can go through this script and then you can analyze what is going on inside this. Okay. Okay, so I have just copied this from internet. Okay, and as you can see, this is we are creating a function that is to get. and then it will call some JSON, that is JavaScript file. Okay, and this is the spreadsheet ID, right? And then in my case, the spreadsheet ID is this. So I'll be copying this spreadsheet ID. This one is my spreadsheet ID. So copy this spreadsheet ID, right? It will communicate with this sheet. So, and then after that, I need to paste it here, right? This is spreadsheet ID. Then after that, I don't think so. So we'll be writing in column B, C, and D all our three data, and then in first it will be printing, will be taking as a serial number, right? So how many data we have collected till now? Okay, now after this deploy, um, see this project, right? And then after that, okay, so we can publish our this web app. We can deploy as web app. Okay, and then it is fetching the data, right? We will fetch the data from a spreadsheet ID. Okay, as if it will done. So name it as whatever you want. So I'll be giving as demo one, right? And you can give this access to anyone. I will be giving this access to anyone within NIT Meghalaya, or let me give it anyone, okay, right? So deploy it as well. Now you need to review the permission. Okay, and then after that you can allow it, simply allow it. Right. So it is done. Now you need to copy this address. Okay, then copy it, right? And then so it is okay. Okay, now close this. Right, we have copied this a link. Okay, so this is our gas ID, right? This is our gas ID. Right, so this is your app ID. Now copy this and then paste it here. So our gas ID has been this string gas ID has been assigned. Right. After this, what we'll be doing is we'll be printing this to our serial monitor that we are trying to connect to our host. So for that, we need to print as serial.print. That is, we are connecting. We're trying to connecting to host, right? And then after that, we'll be printing the name of that host. What is the name of the host? So we can print it as SV. Uh, Given the name of our host as, if you can remember, we have created a variable called name host, which is of type character, and the name of this host is script.google.com, right? So it will print the name of the host, right? And then after that we want to print one line, and then after that we need to check whether our this vmos is has been connected to our host or not. If it has been connected, then we'll be uh, verifying the fingerprint. Okay, then if the fingerprint matches, then only we can communicate with we can start communicating with our server excel sheet, and then we'll be start giving the data, and then that will store the data, right? So after that, we need to check if it is connected or not. So if it is If it is not connected, okay, if it's not connected to our host and our port, that is HTTPS, that is 443, in the as we here I have declared here, okay, 443. So if it is connected, right, so we need if it is not connected, right, if we have used exclamation mark, that is if it is not connected to our host in HTTP port, so we'll be writing we'll be printing it out as a connection failed, and then we'll return it here itself, because it is not able to connect to our host and HTTPS, right? So we can serial dot print line, we can print here as connection failed, connection failed, right? And then we can return here itself, right? Because we are unable to connect to our host, right? And if it is not true, if it has been connected, it has been got connected through our HTTPS port and then host, then we need to check whether our fingerprint matches or not, right? So let me check here whether uh, if client dot verify, that will be fingerprint, and then host, if they matches, right? um, um, and then we can print it as in a serial meter, that's a certificate or fingerprint matches, right? That, let me write here as fingerprint or certificate, so that is certificate only, matches, right? And then after that, if it is matches, then we can start communicating. Or else there is one more condition, that if it does not matches, then we need to do here else singular print that certificate did not matches, does not matches, right? So if it has been gone through till now, what we need to do is we need to make one URL of type string, and then we will be sending it to our host, and that the string itself will contain the value of x, y, and z, and that the our, what we can say, our this URL itself will execute, and then the data will be stored in our Excel sheet, right? So for that, let me create one a variable, that is string type string, and URL as so for that, as we can see, this is our URL, right? So execute script.google.com macros s a, and then our certificate, this gas ID, and then execute. Then after that, if we will be writing execute question mark, and that the value of x equals x, or ADC 0, ADC 0, okay, and then plus y equals ADC 1 plus z equals ADC 2. So if we will execute this, if we will run this, will copy and paste it in our browser, then it will automatically set, or we can say in place of ADC we need to give some that int value or float value, whatever the value, it should not be character, because we are storing the data, right? So we can give instead of this at the place of this ABC, we need to give all the like the values, right? It will store it will take the values from this. Here we discussed that it is reading the data from single unit, that is analog, that pin. Okay, so from the ADC pin, right? If we will copy and paste it in our browser, then it will and instead of this ADC0, we'll be giving some anything 123 and ADC 456, 456, and then ADC2, then any other value. Okay, so 532. Then if it will execute the this code, and then after that it will store it into the access. Right. So in this format we need to create our um, URL, right? So let me do one thing. So what I'll be doing is, I'll be this thing we know. Okay, so we can take it from host, our variable, right? We mentioned here. Okay, this is host script.google.com. So I'll be starting from here, right? And then so for that thing, I need to make this as this is slash macro s. Let me copy this from here. Okay, and then paste here. That's macros slash s and slash. Then after that, plus what we need? We need this is our gas icon. Okay, we had mentioned here. Here this. So I will not using it this thing as here. I'll be using gas underscore id as our variable, and then plus, right? Then after that, I need to use this execute question mark. So that is our string, and then after that we need to give the value of x, y, and then z, right? So plus value of this as question mark, that x equals plus ADC value, ADC0. Okay, the value of this is our int value, right? And then after that will be, again we need to give our value as y equal plus ADC1, right? And then again we are making this as a string, and then we are combining each time this with our that our int data, right? So then again z equals plus abc 0 2, right? And then we'll be using this string as our as an URL, right? So I think till now it is fine. Okay, so after that what we need to do is we need to send this data to our host. Okay, so after this, after creating the URL, what we need to do is we need to request this um, URL. So we'll be printing it in serial pointer, that we are requesting URL, right? That our URL is, what is our URL? The printed as serial dot print that URL, right? Here is mistake, serial print line print, and that is whatever the URL we have made here. Okay, just describe here, it will be printing this URL, right? After that we need to uh, execute, we need to send this to our um, server, right? So for that we will be writing this client dot print right? And then after that, we will be writing this get right, and then URL, right? Our URL plus https, that is version 1.1 we'll be using, and then some tab and then new, right? And then after that, again we need to add our host, that is our host as, and our host will be as host plus, that is host. Then after that again \r/n, right? Then again it is a type of format we need to use it. So after that we can use it as user agent. Okay, and then after that let's make it as built-in build failure. Sorry for the noise. Detectors ESP okay, and I'm connecting connection close. Okay, for this connection close, and then that will be in our /r/n. Okay, and then again /r/n, right? So it will print this thing into our client, right? And then after that we can print we have sent a request in the serial monitor. So serial dot print line, that is the request has been sent. Request sent. Okay, with the URL also we can use this thing request sent, and then after that until unless it is connected we will be using this function as while client is connected. Okay, when client is connected, make a string line, make a string and a variable as line. That will be our client. Dot read string until new line. Okay, until it is new line, you read this, right? Text. Until it is new line, you read. Okay, and then if we get a new line, if line equals um, \r, right? Then what we need to do is we need to print that header has been received and then take it here, right? So headers received, right? And then after that we need to take it here. right? So it will continuously be called again and again with this loop function, right? And then it will call the serial disk send data with the 3 parameter, and then after that it will the function will take it as parameter as input x, y, and z, right? So I think I should use here as x. I think we are using it as x because we do not have that ADC here in this function, right? So that is jet. Right. So I am saving it. Saving has been done, and then now let us compile it. Right. Let me save here, and then it has been saved. Right. We can verify it that whether it is compiling or not. So it is getting compiled. Okay, as we can see. Sorry for the noise here. So let it be compiled. It's still compiling. Okay, what you can do is we need this. It should compile. Okay, whatever you need, you need this.
Anyway, it's near about 2 minutes left. From me, is talking like this.
Right, so comparison is been done. What I will do is I will be using, I will use my VMOS connection which I have made that circuit diagram, and then I will be uploading the code to, I'll dump all this code to my VMOS, VMOS, and then after that we will be going for the testing, right? So let's go and test our module, right? So let's go to the testing.
Window screen. So in that case, we will select window, directly select yes. In your feed, the audio is different from the presentation. Issue in the audio. Actually, here, speaker is coming from this is interesting. That's why I share the video by the listen from the no, dictate sir. Yeah, it's over. Let me take control. Yeah, so I hope you have seen the last part where the activity is recognized in the Excel sheet. One column was there calculating. So I am taking just 10 rows of data and checking with trend data set, a training data set which is not shown in the video. So in the background in the Excel sheet in other tabs, training data set was there. So just 10 rows I am taking, and I am comparing with the different features of the training data sets, and finally I am coming to one conclusion that what is the activity. Okay, so it's clearly seen that after calculating 10 rows, it is deleting the old data and freshly filling up the data, and at the same time it is also reporting the corresponding activity. And along with you can send mails also. We are able to do that. So whenever the activity is, some activity is reported, so that thing can be mailed also. And that mail thing you can code in like that way. If certain for example, for abnormal activity like falling, uh, only for that you will send mail. That system also you can do. Okay, so this is all about the end-to-end system. In case of any query, you can ask me now.
So the session is open to questions from different participants.
We achieved near about 97% accuracy. Till now we have experimented. Mm, and this system is only based on accelerometer. Later on we will extend it with other elements, like I have explained now, IMU sensor, so gyroscope and magnetometer, we can extend that. You can include heart rate sensor also, because depending on the activity your heart rate also can change, so that also extension can be done. Anyway, so just in case of any doubt you may ask me.
So, sir, just waiting for 1 or 2 minutes.
Yeah.
Dr. Soman, we are just waiting for 1 or 2 minutes. And if there are no more questions, then we'll
Yeah, of
officially end
course.
the
Yeah.
session. Okay, so I think then the speaker has like spoken already many things, and there were interactions also. So there are no more questions. So normally the second session of today comes to an end, and Dr. Soman has been delivering lectures since last 3 sessions, including this one. Yesterday evening was his first session, where he talked about the concepts, okay, the uh, uh,
The sensors act.
actuators, yeah, those kind of things he was talking of, and then he gave a nice demonstration through his presentation, and those materials definitely will be available. And then today there were a lot of discussions regarding many problems related to research challenges of IoT, and finally the videos that we have seen. I think many of you have liked it, and links of them will be shared. So with these 3 sessions, he has managed his target. it off nicely, and I think many of us have benefited from that. So we heartily thank Dr. Saman for his presentation, and he has informed me that if participants need to discuss further with him, then they can directly email him. So thank you very
Thank you,
much
sir.
to Dr. Soman. Thank you very much.
Thank you.
Yes,
Thank
sir.
you all the
Welcome.
participants
Thank you
also.
all, all the participants also. So here we'll end for lunch break, and then we'll continue with the last session for today at 2:30. Bye all.
Okay, bye.